Welcome to the September 8th Arborist call. Arborist calls follow a fairly standard format. They're also pretty casual. So we just have a quick intro. We do updates from, for the most part, node development, node developers, ZBRD, Zcashd teams. And then we have a period of time for just open discussions. So we encourage questions or comments throughout. We typically just address those as we go. So at any point, if anyone has anything they'd like to ask about or mention, feel free to just chime in. Arborist calls, we try to keep those focused on protocol development. We talk about everything related to protocol, R&D, timelines, in particular around network upgrades, new protocol features, et cetera. So it's just kind of an open period of time we can all get together and talk about protocol. The purpose is to make what we're doing on the protocol side more transparent for the community, and and have a venue for people that are interested in protocol development to be able to kind of catch up with the teams. Anyone can participate. If there's something you'd like to present, just let me know, and I can get you slotted in. Or if it's something that you'd like the team to discuss at some point, the people on the call, just let me know as well, and we'll get that slotted in also. And then beyond Arborist calls, there's a ton of ways to get involved with Zcash. We have a great community grants program. A number of those folks are always on these calls as well. The community grants committee. We have a Filecoin and ECC grant program we set up. So if you're interested in doing something that would be beneficial to both Filecoin and ECC, or Zcash, I should say, not ECC in particular, then feel free to take a look at that website, see if it's something you might be interested in, or anything you could think of that might be kind of deemed beneficial would be greatly appreciated if you want to apply. And we have a phenomenal R&D Discord where it's all about R&D, engineering, protocol development, wallet development, anything and everything related to Zcash. So encourage you to join that as well. Let's see. And with that, I think I may have I just clicked on the website for the grants. My fault. Okay. And with that, we'll shift over to Merrick, I believe, is going to do the update for ZBRD today.
Yeah, hello, I'll give the Zebra update this time.
Okay.
A week ago, we released beta 14. The CI works really well now, which is amazing. The start command for ZBRD is now the default one. And Zebra used to update its tree state twice for each block once it stopped checkpointing. So we fixed that, and that made the sync faster. And we also fixed a regression in light wallet desyncing. That was caused by using Rayon threads, and we reverted that. And that's the main summary, basically.
What was the thing with Rayon threads? We were looking at some like memory allocations that involved Rayon threads, but what was that issue again?
I think we were deserializing
okay.
Transactions in Rayon threads, and that was unnecessary overhead.
Okay, got you. All right.
Yeah, the PR number is 4933.
Okay.
That reverts it. And
right.
yeah, we're currently making sure that the release process for Zebra release candidates will be smooth.
Okay. Excellent. Okay, very good. Thank you for that. Cool. And oh, by the way, I saw Deirdre's comment, a new engineer.
Oh yeah, we have a new engineer, and they started I think last week. Aria is joining us, and one of their first commits was that instead of doing ZBRD start every time, you can just run ZBRD and it will do ZBRD start as default. And apparently that was a tricky thing to do based on the abscissa library that we use to scaffold all of our commands and config and things like that for our command line configs. because they don't want you to do it like that by default. But welcome to Aria.
Welcome. Yeah, I see Aria as a participant. I tried to promote them, but I don't know if it actually worked. But anyway, we'll have plenty of opportunities to say hello, I'm sure, at some point. All right. Thank you. Thank you, Merrick, for that. Okay, moving on to Zcashd. Quick update on the protocol side. So as everyone's aware, we've been pretty much exclusively focused on mitigating the impact of the shielded transaction load. On the Zcashd side, we put out 510, 520. We talked about that last time, so I won't go into the details. That has seemed to make some pretty substantial improvements on the node side. Our focus now is on speeding up a wallet sync, which I'll talk about on the next slide. There's also an issue that we're working on. A few people have reported, both in the forums and through GitHub, which is an increased memory usage during sync. And some users have actually hit, an OOM condition. So we believe recreated it, and we've identified it kind of an initial fix, which we believe will reduce peak memory usage. So it doesn't appear to be a leak, like things are leaking. It's just because of the amount of processing that we're doing at any given time. It had increased based on the blocks that we were processing and the increased number of shielded transactions. It was driving up peak memory usage, but we've got a few things we're going to be testing out to help out with that over the coming week or so.
Yeah, I think there might actually be more than one contributing factor to some of the out of memory conditions people are seeing, because some of the people who are seeing it are not doing scanning with shielded addresses. So there must be something else in addition to that.
So I noticed that. I think the one you're talking about there is one we were looking at this morning, or you were looking at this morning. They had an 8 gig VM configured, which I've seen like steady state get up to, even a little over 9. So I don't know if we've just gotten to the point that we're exceeding 8, regularly, or it's something else. But
well, there could be other things.
Yeah,
there could be other things that we can optimize memory.
Right. Okay. Nope. It sounds like a great idea. Okay, and then the third item on here, third bullet, Addie from Nighthawk had created a zip proposal that included some fee changes. So we're taking a look at that. Nate in particular, who's been heading up our research around all things proof of stake, interop, et cetera. He's kind of shifted his research focus over to fee mechanism changes, if you will. That's kind of something we've always kind of had for down the road, like something like an EIP 1559 kind of thing. But given the proposal and kind of our priorities for trying to kind of scale well to the load that we're seeing, Nate shifted his research. So if Nate, you want to just kind of give an update on where you're at on that one?
Sure. Yeah. So basically, I'm like coordinating with people at ECC. I think generally we support this kind of proposal, modulo some tweaks or like specific parameters, and then we're also trying to integrate user research and like on-chain research with it to make sure we're understanding the potential impact for all users. And we also, I'm thinking we want this to be like part of a sequence of changes to the fee system that can improve usability over the longer term. So that's sort of where I'm at.
Yeah, and I think that's it's one of the key there. One is the mechanics of of a fee proposal or fee change. The other one is like, are you kind of playing whack-a-mole with what you're trying to do in terms of what you're trying to address, and would you potentially impact, like let's just call it typical usage of Zcash, maybe not some of these larger extreme transactions that we're seeing. But we've been actually, Greg, who's one of our new engineers on core ECC, has been doing some kind of like analysis of historical transactions. So we can actually look at historically what a transaction paid, and then with various potential fee changes, you could look at, okay, well, that transaction would now pay X instead of Y, for example. So we can, we just want to be very careful with something like that, of course. So looks like we have a couple hands up. I believe Daniel was first. I think I saw his hand go up first. So I'll pause there and pass it over to Daniel.
Hi all, thanks, Stephen. So I didn't get a chance to review the 317 zip yet, but we definitely want to talk about it a bit more, like in length, maybe. We do have a concrete proposal that we were writing now. For fees, specifically for ZSA, like our proposal was sort of saying, and I wanted to share this now, but I'll take advantage of this moment. We wanted to say sort of sapling and transparent will stay as is, and then we'll potentially change a little bit like the way that ZSAs are done. Specifically, we wanted to do sort of two things. One is to lower a little bit the price sort of per byte or per action for ZSA in order to incentivize the use of ZSA. And the second thing is that for issuance, we wanted to have an actual sort of fixed fee per issuance and sort of the accompanying smaller fee per output of the issuance, right? Like the way that the issuance works is that when you do the actual issuance, there is some state that's recorded on consensus on the state, and then you're gonna be able to send that those issued assets to different addresses, and that's for every one of those it's an output, right? Like it's not shielded, but because it's transparent, but it's like an output note of the action, right? And so, first of all, I want to hear the feedback from everyone here, because our sort of idea was that we do want to maintain ZEC as the core currency and sort of increase its value with ZSA even. And we also want to prevent sort of trash going into Zcash. So if we put a high fee for issuance, let's say like something round could be just 1 ZEC, it's a little bit random, right? But like it sounds pretty nice. Where actually we wouldn't want all the fee to go to miners necessarily, because then you could get this kind of dump mechanism, but it could go back to sort of either the prosperity fund or to something like the Zcash Foundation fund or the grants committee fund or something that like pay people issuing on Zcash will basically be paying the network itself.
All right.
Yeah.
Is that in one of the zips you already have out there, Daniel? The updates for
we're literally finished writing it as we speak, like in the next week or two.
Okay.
We wanted to push it ASAP. But I guess this one came first. I don't know if now maybe the idea would be to sort of merge them better than having two zips, or we could differentiate the two zips based on ZSA and non-ZSA. I don't care.
Yeah. I mean, yeah, I'm looking forward to that. I worked with the GMU folks on the mechanism study they did, along with Nate, of course, who authored, came up with all the myriad of mechanisms they analyzed. So yeah, looking forward to seeing that. Okay, Addy, I think your hand was next.
Thanks, Stephen. So just want to say thank you to Nate for shifting the priority to this fee mechanism change. I know this is an ongoing topic in the Zcash ecosystem, but just looking at how much the chain has grown in the last 3 months and the blatant use of the block space and the blockchain transaction size and paying still the minimum fee, that is what prompted the research into this. And I've also been coordinating with a lot of and other Zcash developers who support this kind of proportional fee mechanism for the transactions. And based on what Daniel said, like I'm definitely open to review and read the fee structures planned for ZSAs. I'm all in support for incentivizing ZSA transactions. But again, we have to be careful of possible intentional or unintentional spam attack, right? Sub blocks. So we can have all those discussions, but I still view ZSAs as something that is not current right now. It's supposed to come maybe next year or later in the mainnet. So the priority is still, I think, for the transaction fee change. And I did review Nate's last message in the GitHub discussion for the zip. I think the issue that is still out there is there's a lot of wallet code in the mainnet and live use, which is relying on old Bitcoin style fee structures for Zcash transactions. So there will be some changes that have to be made by every wallet developer, exchanges, hardware wallets to adopt this new function. So the delivery of this new updated fee structure has to be very carefully coordinated with the overall ecosystem, so people can actually make transactions after the change happens. So that is yet to be figured out, and I look forward for discussing this with Nate.
Very good. And Nate, I believe your hand's up next, Nate.
Yeah, so Daniel, the proposal for fees related to ZSAs are basically that's a totally different timeline than 317. So I think a prudent step I would like to start working on in addition to 317 is sort of sketching out a roadmap, because even for 317, I think we should maybe break out its deployment into phases, or maybe even separate zips, where the first phase is have wallets implement the rules and deploy that maybe as quickly as possible and learn from what we can from that. And then, you know, a later phase might be changing transaction relay rules. And both of those are like, they don't require consensus changes, so they could happen relatively quickly, which is necessary given the current chain usage. And then beyond that, we want to start thinking about, okay, do we want to change that mechanism or extend it more? So one idea I'm interested in is having the possibility of the fees fluctuating depending on network congestion. And that's sort of one axis. Or other functionality might be on that axis, like maybe what do fees look like for ZSAs? But then a different axis in my mind is sort of the deployment pipeline from wallets to relay rules to consensus rules. And they're not totally orthogonal, they interact, but we can do some functional things without or prior to doing consensus changes, and we probably should be doing that. And then we should be following up and like reinforcing things with consensus changes where we can. So figuring out that roadmap together would be helpful, but I don't want to slow down 317 itself right now. So I want to keep its scope focused on the short-term issue.
Okay, makes total sense. Yeah.
Dara.
Yeah, so I'm less worried about the issue of transparent-only wallets not changing their code, because transparent-only wallets are already responsive to whether transactions are getting into the chain, and they adjust the fee rate based on that. Also, they use a fee rate, which is dependent on the size of the transaction. So for a fully transparent transaction, that's going to be approximately proportional to the number of inputs and outputs anyway, so within a small constant factor. So I would expect that as long as we don't choose the parameters so that the fees are really high, then transparent wallets, even if they don't change their code, are going to just work for the vast majority of transactions.
And Eddie, your hand's up. Did you re-raise it, or is it still up from the prior time? Okay. All right. So Nate, again.
If we want to keep digging in on fees, just let me know when we should stop talking about fees, because I'm going to keep going.
No, go ahead. Yeah.
I think that might be true based on what we know about code, but I want to be cautious about understanding users and use cases, especially once if we're going to do stuff beyond 317, like dynamically adjusting fees.
Yeah.
So
we know that there are definitely some wallets that will have problems because, for example, there's some wallets using the old fixed fee of C's 10,000 Zats.
yeah.
So those will have a problem whenever the transaction would need to pay more than 10 times the base fee, assuming the base fee stays the same. So yeah, there will be wallets that have problems, and my expectation is that users will stop using wallets that can't get the transactions through. But I don't know whether that assumption is justified.
Right. And I also want to be cautious about, so basically I'm a fan of being like cautious and conservative and neutral about usage patterns. So like we all know that the big problem right now is large transactions with many shielded outputs paying the small fixed fee. But in my opinion, addressing that by inhibiting transactions with many outputs might be like a useful short-term thing, but it's kind of a band-aid, and we want to be cautious about different use cases. So if we're proposing a fee proportional to inputs or outputs for all transactions, including transparent, that's going to sweep up a lot of use cases like, mining pools, exchanges, have fund recipient orgs, and things of that nature. So we just, we do need to be cautious. And so I urge people not to get overly focused on this ideal that they might have, that like there's a typical everyday user and they have transactions that look a certain way, and that's who we care about. We need to be cautious about all users, and we also need to be cautious about making assumptions about usage patterns.
I mean, basically, mining pools might have to increase their fees to pool participants slightly, but it's only slightly. And the pool participants, if they're trying to spend those UTXOs, would have to pay the fee anyway per input. So it's only proportional to that, really.
Yeah. So to Nate's point, that's kind of why Greg's been working on modeling the usage pattern, so we can, not just like what we suspect, but we have like, concrete data that shows what we're seeing. Because you can just randomly pop into Block Explorer, look at transactions, and I mean, you can look at, that's one that we're talking about. That's more common, but you do see transactions that I would consider, not in this category of increased load transaction, that are, a couple hundred inputs, several hundred outputs, and so there are use cases where that is common. So, Addie, your hand was back up.
Yeah, I would just say I agree with Dara. It's not a huge change. Like typically the shielded miners have transactions with 50 to 100 inputs or outputs. So it's still overall low fees compared to other chains that are out there. And to Dara's other point, which is some wallets may not work. So does someone know how this will function? Like if someone does set a low fee and broadcast the transaction, should we allow the transaction to be broadcast, or should we plan on filtering it at the light quality level or the node level?
So eventually I would expect that we would impose relay restrictions.
Yeah, I think that's to Nate's point. Yeah, and he was nodding his head, Addie, that kind of a roadmap phase rollout of any potential fee change we might make. So.
Yeah, this was also brought up by the Zip editors when we were reviewing Zip 317. There were several comments that are not yet addressed to that effect about moving and filling in the deployment section of the Zip to basically cover what this is going to be.
All right. Okay. Nate.
Okay. Also, while we're focusing on this topic for roadmap, I want us to think like more broadly about usability. So, for example, I think if we implement a relay rule, and then a user has a wallet that tries to transmit a transaction where the fees are too low, the usability is really terrible. Like, first of all, I'm not even sure if the protocol can make it clear to the wallet that that transaction doesn't follow a policy. So it might quietly just drop the transaction. That's not very good. And then even if it did, wallets would need to respond to that in their UX. So I'm hoping we can push on that front as well as just the nuts and bolts fees and protocol stuff.
All right, Dodger.
Yeah, I just want to check that we still set a default transaction expiry height, don't we?
We do.
Cool.
40 blocks in all of the in the transaction builders that at least we maintain. The default is 40 blocks, if I recall correctly. We obviously don't have any control over what other transaction builders choose to do, and I know for a fact that there are at least several transaction builders out there. You know, the ones again mostly derived from Bitcoin pieces that then added support for generating the Zcash format, where they just hard code a 0 into that field. In fact, I've even seen one where on parsing, it expects that field to be 0 and fails to parse transactions that do set an expiry height. I believe I left them a comment.
Yeah, Greg's analysis. That's one of the things that we do have. We are gathering statistics on is what expiry heights are being set. Just getting histograms over time of how expiry heights are set.
Mm-hmm. Cool. Very good. All right. Excellent. Anything else on this topic at the moment before I go to the next slide?
Dodger, is your hand left up from previous question? Thanks.
Yep. Yeah. All right. Very good. Yeah, great discussion. Thanks everyone on that. Just going to continue. Again, Arborist calls are primarily protocol related, but given the load that we're seeing, I just wanted to also let everyone know we're still, like, our #1 engineering priority is a faster sync for the mobile wallet SDKs. We're working on that, making great progress. The primary beneficiaries of that update would be Edge, Unstoppable, and Nighthawk, who are the wallets built on the SDK. So anyway, that's our priority, and we're looking forward to kind of getting that out. Our plan is to kind of roll and improve sync out in a couple phases at least. The first one would be, some incremental improvements, not kind of our ultimate set of improvements, but hopefully enough to make a fairly impactful difference in how fast wallets sync. So very good. So let's see. Yes, I'm ditto Dodger. I was about to say that too. Google Meet lowering your hand if you if you do anything, you clear your throat, it lowers your hand. But yeah, so very good. All right. Any questions about Addie, your hand's up. Sorry.
So a lot of people in the community have the question of the timeline on the rollout of the updated SDKs. So is there an idea of where and how much progress is done?
Yeah, so and I'll answer your question, but kind of with the caveat that we're it's subject to our own internal testing. So it's kind of hard to put like a definitive date on it. We're getting very close. We'll probably have the iOS SDK updated first, followed shortly thereafter with Android. But we're hopeful we could even have the first iOS SDK update packaged up next week. And again, that's hopeful. That's kind of a target we're shooting for it may take a little longer again based on our internal testing, but potentially as early as late next week. But
yeah, the roadmap here is essentially the next update that comes out for the iOS and Android SDKs will be the one that rolls that includes unified addresses and the migration to unified addresses, because that was necessary to get the code bases into the state where the sync improvements could be applied. So they will include the unified address migration and also internal parallelization of trial decryption. That's the first piece that will roll out, and then the next piece on top of that will be, I believe, the next piece that will be landed is the changes to how the commitment trees and witnesses are updated. I think that's the next nearest piece to completion. And then, so that will then be a incremental bump on top of that, which should be simpler to upgrade because it should only be changing internals. And then full DAG sync beyond that, that's going to be a bit more of a sizable change to the interface that SDK users use potentially. We're still figuring out how the API surface will change for that. But that will come after that point. So,
got it. Thanks for the update. Quick question on that. So the update that's coming next week or soonish, will that have like parallel trial decryption, like doing both Orchard and Sapling? Okay.
Yeah. I'll can't remember if both. I think we implemented it for both of them. I can't quite remember. But there was definitely parallelized trial decryption for Sapling in there. I can't remember if we also plugged it in for Orchard yet.
Well, we did for Zcashd, so it shouldn't be too much for lift to
get the code is there, and I know that it was integrated for Sapling. I just can't remember off the top of my head if we also integrated it yet. I mean, the SDK at the moment doesn't have Orchard support, so it's sort of immaterial from that perspective. But the parallelization code is there. And it does batching based on the batching, I believe, is based on the existing API that's there for saying like scan however many blocks. It will basically just do the batching and parallelism across that chunk of blocks that you the increment that you use there.
So Strad, can you just clarify how much of Orchard will be implemented in the next update?
In the next update, so in the migration to UAs, the spending key backends will have Orchard keys in them, and the SDK itself will not. The SDK itself will, when seeing like a UA, so it will also have support for seeing UAs, but it will not select Orchard for spends. It will select Sapling for spends, and then an update after that will then add support for trial decrypting Orchard outputs to then be able to detect inputs being sent to those pieces.
So just to clarify, we're not exposing UAs that include Orchard components before we're able to receive Orchard funds, because that's.
I will have to go back and check. So the spending keys absolutely will have Orchard components in them, and I believe the UFEKs will as well, because we want that migration step of the databases to. We don't want to have the UFEK users to do two migrations in short succession.
Right. It doesn't matter if the UFEKs do, but the UAs should not have Orchard components before we can
I can't remember if that's currently the case. I will go back and check.
Okay.
In any case, even if seeing an Orchard containing UA, the SDK wallets will ignore the Orchard component of it when sending to a UA in the next update, because and will continue to send to the Sapling components of the UAs, which also actually means that then, because I believe Zec Wallet Lite currently, or Zec Wallet, whichever one it is, currently generates Orchard only UAs, so those would not work with the SDK in the next update, because those UAs wouldn't have Sapling components. Yeah, it would be. Yeah, ideally we would have orchard pieces in there as well, but yeah, given we're having to prioritize the performance stuff,
Right.
That's the trade-off here. But orchard, hopefully, once we've got those pieces in, will be significantly easier to bring in.
Okay. All right, Dara, I think you may be muted.
What crate should I file an issue on to make sure that we're not outputting UAs for production commands yet?
It's probably both of the SDK libraries.
Yeah,
Actually,
okay, I thought so.
Make an issue on the Zcash because that's where the
okay.
Yeah, that seems right. I can move it from there.
Okay. All right, very good. All right, well, that was that was my last slide. So I'm gonna stop sharing. A little easier to see that way. And Addie, it looks like your hand's up.
Yeah, since we're on the wallet discussion, just wanted to hear from the Zebra team about their progress. What is their timeline on adding the wallet functionality to the Zebra node?
It's not on the roadmap at the moment. So we've been focusing on adding the drop-in light wallet support, and now we're looking towards get block template. There's no plans right now to have a wallet built into Zebra itself. That may change in the future, but right now it's not on the roadmap.
Got it. So maybe someone can talk about the use cases of Zebra. I believe one is being a consumer and serving the blocks. Are you also planning to be a mining client?
We're not planning to build a miner into Zebra, but we're planning to add the get block template functionality that will allow miners to use Zebra to generate the block template that they will then mine using whatever software they use.
Got it. Thanks.
All right, very good. Anything else anyone wanted to bring up today or discuss?
Yeah, I think I would like to maybe share a little bit of updates in terms of the ZSA project.
Yeah, go ahead.
So it's going to be quick, but two things that sort of came out of also discussions from like at ZCon and sort of follow-up discussions we had internally. The first one is that like we're going to submit a sort of I don't know if I would call it a reshuffle or a redoing of something or some sort of the actual proposal to basically distinguish between two types of milestones that we had there. One is sort of everything that comes from the design to the implementation. And the other one is everything that's related to sort of deployment and sort of longer term testing. That way we can really like make the work to differentiate between the two. So like I just wanted to make sure that was clear to everyone, and we're gonna like sort of submit it as an update. And I don't know what the formal process is for that. Maybe I should talk to Adi or something from the grants committee, but just yeah, that's one thing. And sort of the other thing is that we're really advancing with implementation. We're more or less halfway with the circuit. As of now, it seems like we may be exceeding some of the limits that we had hoped to achieve in terms of circuit size. So it may be that we need to rethink a little bit or reshuffle some of the constraints. I mean, you know, at some point when we finish with most of the implementation there, we should have a talk with Strat and Dara to make sure that we figure out any optimizations in terms of space there. Also based on the talk that Strat gave at ZCon, that was really inspiring.
So roughly how far above 2 to the 11 are you at the moment? In terms of
I don't actually have the concrete number, and I don't think Aurel is in the call right now. And we're also not finished with all the sort of extra constraints we wanted to add. So let me get that like let's get that done probably in the next weeks. And we'll definitely share that.
Yeah, because there are other optimizations that we can do with in the rest of the circuit if we need to.
Sure.
Yeah, and
makes sense.
Yeah, we can also like look at different, going back to my talk, we can look at different trade-offs as the circuit as a whole, depending on, once we know what sort of space constraints we're dealing with for the new components. Yeah,
because I guess like
go on.
No, yeah, I was just going to say that the more expensive part is probably not the fact that we're adding an extra hash, but we're adding an extra sort of round of the Sinsemilla hash, because to add the type in this kind of valuable way.
Yeah, the other thing is that we're replacing fixed base multiplications with variable base in some places. I think those were only the value commitments, so it's only a 64-bit scalar at the moment. But if we wanted to extend that to 128-bit values, that might also be an issue. But I think that the current way that we're doing variable base multiplication is suboptimal anyway. I think that there's more fairly low-hanging fruits to be had there.
All right.
Yeah,
sounds
I was
good.
just going to. That's the point I was going to
for
raise as well. There was if you'd seen the comments related to the U128 value.
I didn't personally, but maybe some of the other team members.
Okay,
did.
yeah, this was just a comment that was raised somewhere
up
to do with the fact that like if bridging Ethereum specifically, like ETH in the way that the ETH token and denomination is defined, it uses a value like a unit of account that ends up being larger than a U64 can hold.
Right.
So to be able to represent like way, the ETH in ZSA, we would need to be able to represent nodes with larger than two U64 values.
Yeah.
So one proposal had been,
we discussed it at some point, so we'll make sure that it's on the top of the list there.
Yeah, there's been a note on the. I remember yesterday we made a note on whichever one's the one that has the circuit changes in it. There was some notes we made during ZipSync there.
Okay.
Which also would affect, like it would be also affected in how like Sinsemilla gets extended and so on. But then more generally, we think about whether, because like ERC20s in general, you're allowed to represent up to a U256 because that's the unit of that's the word size in Ethereum, and that just breaks the way that value balancing works. So we're not going to support that, I think, but. Someone may want to do a brief survey of like, as far as like bridging goes, like what if there are anything that might be excluded based on U64 versus U128 versus U256 for representing values.
Yeah, I mean we could potentially do 192 as well, and that would fit in the range constraints.
Yeah, but that becomes a bit more awkward and outside the circuit.
Yeah, it does. The other thing I was going to mention is that there was an omission in one of the zips in the circuit section about how dummies are done. So if split is 1, then you need to enforce that V old is non-zero, so that you're still enforcing the Merkle path validity. So that
because it's not enough to add to. Oh, I see. You're saying it's not enough to take a previous split output node.
Well,
or not a split, sorry, a dummy node or something like.
The point is specifically
like a zero value node that exists in Merkle root.
Well, that's precisely the thing. If you if the definition of a dummy node is that its value is 0 and that turns off the commitment tree check. But you can't have the commitment tree check turned off for a split node. Essentially, this is just, there needs to be a constraint that you either have a split node or a dummy node, but not both simultaneously.
But it's different in the sense that we're splitting the circuit also into ZEC node or non-ZEC node. And for ZEC node, we allow dummy nodes, but for non-ZEC node, we don't.
Well, that also wasn't that also wasn't
Yeah,
present in
there
the
was-
zip. That was the alternative that we discussed in ZipSync, was that you could either represent it as just tying dummy verse split together, or base it on whether the value base, the type field was a ZEC note or a non-ZEC note. And in either case, it needs to be clear in the zip that that's the
there was a missing
constraint
conformance.
exists.
Yeah, there was a missing conformance
Okay.
requirement either way.
Thanks for pointing out.
Nate, I want to get to Nate. His hands up.
Oh yeah, I said it in chat. It was about the precision. So I just glanced. It looks like Cosmos's interchain asset transfer also uses 256 bits. I don't know why, but anyway.
Probably because of Ethereum.
Yeah, one thing is that Ethereum ERC20 lets assets define their precision. So I'm really curious, if you just looked across all the assets on the chain, how much precision do any of them actually need? But that's still no guarantee that there won't be some weird high precision asset.
Well, the reason I'm not really worried is that if you're defining a bridge, then you can always require that the values on the other side of the bridge have zeros at the end, so that you don't have excess precision. And those can be binary zeros or decimal zeros, depending on how the token is defined.
Yeah, there are ways around it, but they just need to be planned for.
All right, and then we have a question in the Q&A. It says, as far as I can tell, unified spending keys and unified full viewing keys aren't concepts that exist at the protocol level.
I am
so
just responding to that.
Oh, okay. You want to just answer it live, Chris?
Sure, I can answer it live. So unified full viewing keys are a concept that's defined in ZIP 316. And they have a well-specified encoding that is similar to the encoding for unified addresses. So unified spending keys are also used. I would say at the protocol level, they are not necessarily defined, but we have a well-established derivation for unified spending keys in ZIP 316. And we are currently in the process of, we're actually close to merging a PR that defines a unified spending key encoding for crossing FFI boundaries. But that encoding, we don't intend for unified spending keys to essentially be passed around or used for backup, since they are defined to be derived according to, derived from a mnemonic seed. And again, ZIP 316 defines that derivation process. The important thing is that the components of a spend authority essentially be derived in parallel, or according to account information and so forth, from the mnemonic seed. So because we don't want unified keys that are sort of a mishmash of different spending authorities, that makes it harder to reason about privacy properties, essentially. So I also typed part of that answer into the Q&A.
Oh, okay. All right. Very good.
The way to think about the way to think about it conceptually is that unified addresses are intended, they are designed and intended to be passed around to users, in particular conveyed from a recipient to a sender, to be passed back. Unified full viewing keys are somewhat they're intended to be passed around, enabled to be passed around to people, but to a smaller set of people who you're willing to give, or people or entities you're willing to give viewing capability to. Hence, they also have an encoding, and we use the same encoding mechanism as for unified addresses, because the properties we want to enforce and preserve about the UFVKs when passing around to users are similar to those needed for unified addresses. Unified spending keys, you don't want to ever give out, because they are your root of spend authority. And if you are giving those out, the giving out individual spending keys is generally an indication of the wrong approach being taken for how the funds are managed, because passing around individual spending keys is very risky. It is the root of spend authority. It is equivalent to, well, you're cloning yourself, your sense of self, essentially, as far as the control of funds goes. So we don't really want those to be what gets passed around.
I'll make an analogy here too. If you're familiar with setting up SSH keys, you generally don't want to copy your private SSH keys off of a machine and put them on another machine. Instead, you want to go onto that other machine and generate a new set of keys, and then distribute the public keys for those, so that you're never moving that secret information in a way that can be captured.
Yeah, the affordance relaxed here within the key, like the accounts model, is that the mnemonic seed phrase is essentially the backup for when you need to load back in to recover, but it still is like an action that shouldn't be taken lightly and should only be done carefully, versus addresses and viewing keys, which we want to be far more far easier for people to interact with.
Okay. All right, Dodger.
One thing we should bear in mind when we're thinking about unified spending keys is that it's entirely possible that in the not too distant future, different keys will live in different places. So if you think about the work that's going on to add shielded support for Zcash to Trezor, to Ledger, that we're likely to have the ability for hardware devices to handle transparent and sapling keys, but not orchard, at least for now. So that's something that's working.
Or orchard, but not sapling, depending on exactly when that work is finished.
Yeah.
So yeah, there's that's just something to bear in mind for when from a user experience perspective of how we want to be able to manage that sort of thing.
Yeah, that's another example of why having a unified spending key encoding that people pass around is a misfeature, and we don't want to have it, because updates to, like, if you add a new spending pool, a new place for funds to live, you would have to go around and update every single one of those USKs that have ever come into existence. And if a user believes that, oh, they've backed up that USK, they now have access to all of their funds going forward, that is false. Whereas you get that property from a mnemonic seed phrase. In the case of like if we were able to get like some of the recipients within the key tree onto a hardware wallet, but not all of them, the mechanism for that essentially would be that the hardware wallets may have their seed phrase that's doing controlling one piece, and then if you gain access to that seed phrase, which most hardware wallets still let you store a backup of it, then the orchard component could be derived separately and then combined into the UFVK that would have been derived were all of the managed from the hardware wallet, and then it's the UFVK that then gets passed around and treated as the view capability. And then the moment that orchard support were to land in the hardware wallet, then you could move from accessing the spending key for orchard off the wallet to accessing it only on the wallet, for instance. But it really then comes back to the only time you ever access an individual spending key is when you need that particular capability to be able to spend funds. And otherwise you don't treat it as anything that gets passed around.
All right, very good. Another question, looks like there's another question in there. Okay, one more question about unified spinning keys, unified viewing keys. Are they not yet intended to be part of the public interface? They're doc hidden in Libra Zcash. I'm not sure if that means they're still unstable.
Are you referring to?
I can answer that.
The published version.
So in Libra Zcash, unified full viewing keys as a type were first introduced into the Zcash client backend crate. That is not where they are intended to live long term. These are more general types that should be moved out of that crate. They were introduced just for use in the wallets initially. So they are currently doc hidden because they're expected to move within the hierarchy of Libra Zcash crates.
Okay. All right. Got it. Thank you, Chris.
And in general, yeah, doc hidden things are unstable. So yeah, that's a good inference.
Yeah, we're actually also introducing an explicit unstable feature flag that will be used to guard the unified spending key encoding, because it is intended just for use in wallets. And you know, I don't know exactly what our plan will be for removing that from unstable features, but you know, it is accessible to users who want to use it with the knowledge that you know, we're trying to get it right from the outset, but there may be changes required later.
Yeah, like like, for example, one of the motivations for defining that encoding is if people want to use like a React Native style system, the way that React Native ends up encoding with the backend requires everything to be encoded as like ASCII strings, which is a somewhat frustrating limitation as someone who's writing Rust and likes to have just represent things as nice types and things. So this is sort of an affordance to enable that kind of use case where you can then just take this binary encoding and hex encode it across your internal FFI, but it's again intended as an internal affordance rather than something that should be considered persistable and storable and so on.
All right, very good. I think that was the last of the questions. Anyone have anything else before we wrap up? Nope. All right. Everyone have a good rest of the day, a good weekend, and yeah, we'll catch up in Discord. Thanks, everyone. Great discussion today.
Thank you.
Thank you all.
Cheerio.
Yeah.
Bye.
Bye.